So the most dangerous part is the blast right when it happens and the falling pieces of rock. Eruptions also have sulfur dioxide gas, SO2, which can go into the atmosphere and form sulfuric acid droplets. And that pollution can be also harmful. That's the most common kind of pollution we see in the atmosphere that produces haze. But it comes out pretty quickly near the eruption. It depends on the wind direction. It depends whether it's raining to wash it out. But if the eruption is strong enough, it will pump this gas up into the stratosphere, which is the layer above where we live, where there's no rain to wash it out. And then it can be blown around the world and last for a couple years. And if there's enough SO2 producing a thin layer of sulfuric acid clouds, that can reflect sunlight and cause cooling.
So, is there a way to tell this early on in the process if this is that kind of explosion?
Yes, we have satellites that can measure the SO2 gas. So we can measure that within a day after the eruption. And I've seen no reports of a lot of SO2 from this eruption.
Have there historically been volcanoes that have had a major impact on our climate over a longer period of time?
Oh, absolutely. The last big eruption was Mount Pinatubo in 1991 in the Philippines. And that put up so much sulfur, 20 million tons, that it cooled the global climate by about a half a degree Celsius or about 1 degree Fahrenheit for a couple years. And so that next year was quite a bit cooler. In fact, in Hudson Bay, the sea ice that forms in the winter lasted an extra month that summer, and the polar bears that lived there were able to thrive. They could go hunting more, they could have more bear cubs, and they called those the Pinatubo bears because there was many more of them born and survived in 1992 than other years.